Hey everyone, this is Mayur. Welcome to ML Works. This is the fourth part of the computer vision basics, and here we'll be talking about segmentation. So in the previous video, we have discussed something called as edges, corners, and a few basic features, and also did something called as what image enhancement and image cleaning, and also erosion, dilation, some of the common features available in OpenCV, okay, to manipulate images. So in this video, we'll be talking about segmentation. Consider if you have images with what multiple objects inside your images. Consider you have a box, inside that you have toys. Okay, so box is one of the object and the toys inside it are the different objects. Okay, so segmentation, what it does is it will what create bounding boxes, or it will segment those different objects separately. Okay, to do this, what we need is something called as image contouring. Okay, what it does is it tries to create a curve around your object or the shape. Okay, and because it has the same intensity, so that is one of the reason why image contouring is successful for what segmentation process. Okay, so without taking a lot of time, just get started with what image segmentation. So first what we'll do is just import the libraries. First is we are importing CV2, which is OpenCV, and for plotting we are doing something matplotlib we are taking up, and then for numerical calculation we are using numpy. Okay, so next what we are doing is we are importing an image using CV2, and by default it will be reading it as BGR format, blue, green, red, and we are converting into RGB, which we normally see, okay, when we are clicking pictures, and we are converting that back to what grayscale. So image contouring is what it will be much more effective when we are doing it what when you have an object white color and a background of black color. Okay, so it will be much more effective. So that's why we are converting into grayscale image. Okay, and this is and what we do is next is, since there is a gray, there is what black, white, gray scale in this image, what we do is we convert it into black and white purely. So what we do for that is we apply something called as binary threshold on top of this image. So here if we see cv2.threshold, okay, and we are sending our grayscale image, and now we want to convert it into black and white. So what we do is we give a threshold of 201. So any pixel value which is less than 201 will be turned into 0, that is black, and otherwise it will be turned into 255, which is white. So majority of our, if we run this one, so if majority of our pixels right here and here, those are lying what bit less than 201 value, pixel value, so it is turned into black, and which are greater than 201 are appearing as white here. Okay, so we are also applying this threshold binary. This is for converting into what black and white. Okay, and the next what we do is we are, since we have this clear distinction between what our object and the background, we apply contours on top of this image now. Okay, find contours, there is something called a cv2.find contours, and here we pass our binary image, that is black and white, which we generated in the previous cell. And here we have some other functions called as retrieval tree. So what it will do, right, so consider you have what, as I said earlier, right, there are like multiple objects. Okay, one is your box, and inside that box you have objects like what, toys. So there is the box is your parent object. Okay, and there is something, your toys are the what, child objects. So we create an hierarchy from this retrieval tree. And also this chain approx symbol is nothing but a technique for what, uh, pointing out the dots on top of your objects, how you want to point. Either for, consider you have what, a line. Okay, for representing a line you just need 2 points, you don't need what, a list of points to represent a line. You can what, use 2 points to what, represent a line. So this is a way to what, reduce the number of points required using this technique, chain approx simple. It will reduce the number of points and thus reducing the memory required for representing the objects or contours. Okay, so we are generating what, contours and hierarchy from this find contours, and once the contours are found we are applying what, draw contours. There is some function called as draw contours. We give our contours, and then we want the color we are applying, and this is the depth again, I guess. So let's apply this. Okay, so we get a boundary on it. So these are the contours actually which is generated for this image, this red color line. So this red color line, and this is another line which is enclosed inside, because all these red color line represent the same intensity level. So what are contours? Contours are nothing but you have an objects, and the boundaries of those objects will have what same intensity of color. So contours are represent those intensity. Okay, it is as simple as that. Once we find out this contours, we are normally, what if you can see from this contours, we are almost segmenting our what objects from our background here. Okay, so this is the part where the contours are helpful. Finding contours is helpful. We are segmenting this hand from the background. Now we have algorithms. Before going to the algorithm, right, what I'll do is, since we have all identified these contours, we can also identify what from these contours we can identify the area, perimeter, center of all the objects around whose contours are present. We can identify all these called as parameters. Area parameter we can find out, perimeter we can find out, and center. So now this is the technique which we have used from what this one, like CV2 dot find contours. So what we can do, right, there is something called as KMeans clustering. Using that we can also what segment our objects. Consider you have what black and white image, and K-means clustering, what it does, the pixel values which are closer together, it will group them together. Okay, so it is an unsupervised learning algorithm where you just pass your data set, and wherever your image has different set of colors, okay, it will try to what cluster them together and represent it as what separate object. So for this, what we'll do is, let's get started with this one. Actually, using K-means clustering, we're trying to what segment objects. Okay, so here what I'll do is, I'm what loading an image of flower. Okay, and if we see in this image, there are particularly three colors. Okay, major are three colors. One is white, and there are two, a green color which is under shade, and the other one is under sun. So there are two different colors. Okay, when we are looking at it, we can clearly see this is looking like a light green, and this is dark green. Okay, these are dark green, and whenever it is under the sun, it is looking light green. So what we do now using K-means clustering is, we want to segment each of these colors. Based on these colors, we will segment the objects. Okay, so what we'll do first is, we'll convert our 2D array of pixel and 3 color channel. We have here just an what manipulation of arrays, reshaping our array here. Okay, and then converting into numpy float 32. So once this is done, so since we are clustering, right, since we are clustering these colors, there should be a stopping criteria for what K-means clustering to stop. Okay, for that what we do is, we set a criteria here, either the epsilon value, that is nothing but the accuracy value, or the maximum iterations. Okay, so here we are giving the max iteration as 10 and epsilon value as 1. So accuracy of 1, we are waiting for accuracy of 1, or either once if the algorithm runs for 10 iteration, we have to stop the algorithm. So this is the criteria for stopping the K-means clustering. Okay, and here we are selecting random centers for K-means clustering to initialize. Okay, and let's see, let's apply this one. Let's see. Yep, so we have what found the centers, labels, and retrieval value, and here we have given three colors. K is equal to 3 based on the number of colors we noticed here. One is white and the two different shades of green. So K is equal to 3. We can what change this value and what see how it matters. So since we ran this cell now, what we'll do is segmented data reshape and labels dot reshape. Let's just plot this line here. What happens is, so we are like converting actually. So we are segmenting the data which we have what already we found out here, right? Segmented data based on the labels. Based on the labels, we are segmenting the data, and we are what just plotting at, and we can see here light green, dark green, and white color. Now what we'll do next is, we have to segment out the objects which we don't want. For example, if we don't want any of this what leaves here, we just want to look at the flower. What we can do is we can totally ignore these other labels. Okay, so we are doing something called as visualize one segment. There are three segments here. One is this dark green, light green, and white. So we want to visualize only the white part. So for that, this is just plotting the same thing here. Okay, one segment of the flower. Because here if you see, right, the label reshape is equal to 2. So we are just looking at the second class. Second class means the white color. Okay, and we have to now mask the region if required. We can mask the region if required. Masking means converting the pixel into 0 and completely ignoring that particular range of pixels. Okay, so for instance, if we see here, label reshape is equal to 2, and all converting into all the values of the pixels are converted to 0. So if we see here, if we run this one, so if you see here, since label 2 is 0, our white color flower appears black. Now what I'll do is I'll take this one as 0, and yeah, 0, not 0, 2 as 0. Or 2, I'll just put this as also 0, because these are different colors. This is dark green probably, or this is light green. Okay, we are converting that to 0. Yeah, so all the other aspects of this what clustering, right, it is turned into 0, and only the region that is labeled 2 is appearing as white. Okay, so we achieved all this. What we have clustered our flower from what other clusters. Now what I'll do is I'll change the number of clusters we have. Consider if I apply it as like 5 clusters. Okay, and just I'll go back and reload the image. So I have applied the 5. Okay, it is running. Okay, and let's see. So there are different aspects now. If we see here, there is this color, this is white, there is this color, and there is also this color, dark green, and this is also another color. So it is what trying to segment different colors on top of this image. Let's apply this as what here. If we apply, let's see what happens. So we are looking at label 2, which is again I guess this is again flower part, I guess. Let's see what happens when we do 1. Okay, this is the other flowers. This is either light green, I guess. No, this is the dark green part. And let's see for 0. Okay, this is under the sun, I guess. No, this is the shaded part which is not appearing in front of sun. So this is the one. Okay, so similarly, like 3 we have. Okay, this is the part which is coming under sun, and all other things are what blacked out. Okay, so there is also what different aspects to this colors. Actually, if you see here, this is another shade of color. Yeah, so this one. So we are able to what segment colors like this. Okay, let's see here. If I go back here now, so we are not what masking the other aspects here. These colors are not masked. So what I'll do now, copy these two here, and I'll just do this 3 and 4. Now we have this white alone because we did not mask 2, label 2. Now if I want to capture something else, okay, the other leaves, and I masked all the other colors. These colors look similar, right? Yeah, these colors look similar. So cool, right? So we are able to mask different objects based on the colors using KMeans clustering. Okay, we are almost done with this video with the segmentation aspects. So what we learned today is we learned what is image contouring and the different algorithms. Either we can do it using KMeans clustering, we can do contouring or identify segments in your object in your image. Otherwise you can use something called as find contours from OpenCV too. Okay, so for this video we are almost done now, and I'll catch you up in the next video. Thank you.